NASA has released the first image from the world's most advanced space telescope, and it's certainly impressive. This is the deepest, most detailed view of the universe ever captured. The picture shows elements of the universe as they were 13 billion years ago, reshaping our understanding of the cosmos. Now, part of the image shows light from soon after the Big Bang. It's the first of several pictures to be revealed over the next few days. Well, Martin Ward's Emeritus Professor of Astronomy at Durham University and joins us now. And this is exciting stuff. I mean, how excited are you about these images?
Well, very excited because this project, this mission, the Webb telescope, has been about a quarter of a century in the making, and many hurdles have been overcome. Indeed, it was nearly cancelled by budget overruns. And now it's finally where it should be, 1.5 million kilometres from the Earth. And the first images are spectacular. Only the first one was released yesterday, and now we're beginning to see the other 4, which are publicity shots, essentially, of various aspects of the universe.
And what could they show? I mean, we're looking at them, they look dazzling. Talk us through how important they are and what you're hoping to see within them.
Yeah, well, I think in the time available, just concentrating on 2. The first one that was released is of distant galaxies that are seen behind a cluster of galaxies, many galaxies, and they're acting as a magnifying glass. This all sounds a bit weird, but gravity is acting as a magnifying, and that means we can see the distant galaxies more clearly near the beginning of the universe. So that's really tremendously exciting. The other thing it's going to do is look at extrasolar planets. There are 8 planets in our solar system. There were 9, but Pluto got downgraded to a minor planet. But there are about 5,000 other planets known beyond the solar system, and we'd really like to know what they're like. And what the James Webb will do is to look at their atmospheres and see what they're made of. And perhaps, I say perhaps, eventually we might see some evidence for biological activity. We haven't yet, but that is one of the possibilities that the Webb might show us.
Well, I hope that doesn't take another quarter of a century. Well, what happens next, though? I mean, what research might these images lend themselves to?
Well, basically, where we are in the universe, how galaxies came to be. Our galaxy is called the Milky Way, and when you go out on a clear night, if you're away from street lights, you'll see this band of stars. That's our galaxy, and we're in the middle of it, or not the middle, on the outskirts, which is why you see a band. But there are millions, billions and billions of galaxies, and we'd like to know how they came to be after the Big Bang. Probably black holes, another interesting topic, had some role to play, and what the Webb will do, how the galaxies came to be assembled and how they evolved from 13.5 billion years ago, because that's how long it took the light to travel to us. So the Webb's like a time machine, looking back in time, because light took that length of time to reach us.
In terms of understanding those other galaxies, where are we and how far do you think we can realistically go in our lifetimes? And if you can't see me, I'm a little bit younger than you, but you get the gist.
Yes, well, we can't, at some point, we run out of stars, because the stars had to form at some stage. And when there were no stars, there were no galaxies. So we're getting very close to the first generation of galaxies, the first formation of them. And another thing which we'll be doing, which is, it adds to the value of the Webb, is using supercomputers to model what we're seeing so that our theories can be tested. It's all very well having beautiful pictures. Beautiful pictures are wonderful things. You've seen them from the Hubble. But we need the theory to understand how these things actually came about. So it's going to be a combination of beautiful pictures, understanding what they mean, and the modeling of theorists and big computers to see if we can predict what's actually been going on.
It really is amazing stuff. Thank you for talking us through it. Martin Ward at Durham University, thank you very much.